Okay, they say a problem is Mr. X said that the mean fat contents in grams of K types of pastry from his bakery is no more than 16 grams. So this is called a problem statement. Okay, someone trying to, okay. So now how are you going to find out? Is it possible for you to stay in the shop and all the K types of bakery baked by Mr. X, you go there one by one and determine it? Is it possible for you to cover the whole population? Or the answer is no. Am I right? So if no, then how? How are we going to solve this problem? How are we going to know whatever Mr. X said is true or not? So the population is too big and it keeps going on and on. He baked so we have the limitation. It's impossible for us to cover the whole population. So what is the population in this case? The population in this case, all the K types of pastry baked all the K types of pastry baked in Mr. K, Mr. X bakery. Right? So this is a population. So what is our limitation? It's impossible for us to take every single pastry. Maybe Mr. X is producing thousands of pastry a day. I don't know. Am I right? Am I going to take each pastry and I'm going to taste it, go and find the fat content one by one? Definitely no. And in real life, normal people like us, is it possible for us to get the fat content? Definitely no. You must need an expert. So this is all our limitation. So if you want to do this, what you need to do, you need someone to help you to find the fat content. Am I right? Okay, so that is a population too big. Okay, second thing, what is our parameter of interest? What do you want to find out about the population? That is called the parameter of interest. What are we trying to find out? Yes, we want to find out not the fat content, not the fat content. Please take note. We are not finding the fat content in each baker, each pastry. We are finding the mean fat content. Okay. Mu. Okay, we can say the mean fat content mu. Okay, you want to let the fat content be F. So it's up to you, the symbol you use. So we are trying to find that. So how to find? Population is too big. Cannot cover everyone. So what to do? Yes. So that is the reason why we say sample. So that is the reason why we answer the question, why sampling? Why you take samples? Because the population is too big. The limitation that we have. Limitation is impossible to study the whole population of pastry made by Mr. X. It's too time consuming, it's too costly. So now, when we say sampling, how should we select the sample? So now we ask ourselves how to select the sample. How to select the sample? Yes, first, the sample must be a random samples. The sample must be a random sample. So what do you mean by random sample then? What do you mean by the random sample? So random sample. So you explain the meaning of random samples. That means every pastry have an equal chance to be selected as part of the sample. Okay, then after we have selected the sample as what stated in the example 7 there, correct? So what should we do with that sample? Okay, so we select the sample already. So what theorem do we base on later to help us to predict the true population mean? So we calculate. So the second step is we calculate the sample mean. Am I right? So we put F bar, and in the textbook is 30. So how do we know that the sample size is 30? So you calculate the sample. So my question is, based on what we select this sample size? So why should we calculate the sample mean? What are we going to do with it? Based on what theorem we are going to follow that? Yes. So when we talk about all this, so we bring in the concept of central limit theorem. Okay, do you know why they put the word limit there? Do you know why they put the word limit there? Can someone tell me? Okay, if the population is not normally distributed, then by terms of rule, if n is greater than 30, then the sample mean will be normally distributed, with the mean equal to the population mean and the standard deviation equal to the population standard deviation divided by square root of n. So that is central limit theorem. But in this case, do we know the population mean? The population standard deviation, do we know? We don't have. So now what should we do? We don't have population standard deviation, correct? So now what should we do? Everyone? Okay, so from there, we explain central limit theorem there. Then we got the sample mean as 15.6 and sample standard deviation as 1.36. So now, since we don't have the population standard deviation, we make an assumption. Assume this sample standard deviation as the population standard deviation. 15.9, yes, thank you. So this is the first assumption that you make. You assume, because you don't have the population standard deviation, so you assume the sample, this sample standard deviation as the population standard deviation. So now, how are we going to go about it to predict? So the next step and what to do with it. So now we want to use this sample mean. Can I move to the next page? Okay. So now, number 5. We are going to use this sample mean that is to make a prediction of true population mean. In this case, I write down properly because I'm talking about mean fat content. I have to be very specific. Okay, we are going to use this sample mean to make a predictions of the true population mean fat content of K types of pastry made by Mr. X based on a certain confidence level. In this case, example, 95% confidence level. So now Mr. is going to explain to you what do you mean by 95% confidence level so that we can get (15.9). That is from your textbook. Just now I wrote wrongly, okay? That means you didn't count. Okay, so what do you mean by 95% confidence interval? That means the confidence level is 95. So what do you mean by 95% confidence level? So we are going to explain this part. Okay, when I say 95% confidence level, it means that if I take 100 different samples, okay? The prediction of the mean okay, in this case, I add some more mean fat content. The prediction of the population mean will contain the true mean. That means it will capture the population mean. The prediction of the population mean content, sorry. The prediction of the population mean content from 95 samples will capture the true population mean. That is the meaning. Because every sample, correct, you will have a different interval of the true mean. So, but 95 of them will capture, which means that later I will talk more about this later, okay? So can or not? So that is the meaning of confidence level. Okay, so now I want to go into the real one. Okay, how to calculate? How to calculate confidence interval? Can I move on? Okay. How to calculate confidence interval. Okay, so first thing, the sample mean. The sample mean fat content of 15.9 gram is the point estimator. That means, is it possible for the population mean to be equal to 15.9? Definitely, the chances is 0. Why? because we know that probability for a particular value of variable to happen in a normal distribution is equal to 0. So we call this a point estimator. Why I call this a point estimator? Because according to central limit theorem, okay, my sample mean distribution will be normally distributed, correct? Hello? Okay, so we assume this is equal to X bar. In our case here, this is equal to 15.9 gram, the middle. Clear? So we call this a point estimator. Okay, now we have to go back to our standard score. Still remember the standard score? What is the standard score for 15.9? Good, 0. So this is normally distributed, 0 and 1. Correct? Okay, good. Now, we are talking about 95%. Okay, when you talk about 95% confidence level, I told you already, what is the meaning? That means 100 samples, the prediction of the population mean fact content from 95 samples will capture the true population mean. That is the meaning of 95% confidence level. So now from this diagram, means I have to find the corresponding z-score. Symmetrical along here. So this is my prediction of the lowest possible. And this is my prediction of highest possible. And here is 0.95. Okay, can you please tell me what is the highest and lowest possible of my Z? So every confidence level, we have the corresponding of the standard score. We call it Z alpha over 2. Can you use your graphic calculator and tell me what is my Z alpha over 2 here? Hello? Can someone tell me what is the Z alpha over 2 if my confidence level is 95? Huh? Cannot be. Cannot be 13.2. How to find Z alpha over 2? One side will be positive, one side will be negative. Yes, please use inverse norm. So this is something that you have to remember because I can change the confidence level. And you put center. Those without center, you should know what to do. Can I have the value? Yes, 1.96. Hello, you round off or not? Here is negative 1.96. Okay, now, just now I told you already. So that means our center here will be your X bar. Correct? And the standard deviation, we know that is a population standard deviation. Okay. Divide by square root of n. I put generally X so that we can get the general formula. Okay, can you tell me what is the highest possible predicted mean? Can you tell me what is the highest possible predicted mean from here? How to calculate this? Still remember the relationship between Z and the standard score? We say Z is equal to X minus mean over standard deviation. Still remember this formula? Class? Are you okay? Okay, so I move to the next page, huh? Okay, we want to calculate highest possible predicted mean. I let be F. Sorry. The symbol I use very important. Huh? I let this be highest possible predicted. Okay, so I go back to here. Highest predicted. Huh? So this is mu H. Can or not? So I have to put in here. This is my mu H. Got it? The corresponding is 1.96. Yeah. So I put into the formula mu H minus F X bar. I put a general one. Sorry. Divided by standard deviation over square root of n. This is equal to 1.96, correct? If the confidence level is 95. If not, if we want to write general, we will put this as Z alpha over 2. Can or not? So from here, when I rearrange, I will get my highest possible predicted mean is equal to plus Z alpha over 2 standard deviation over square root of n. Okay, so can or not? Okay, so lowest possible. I don't want to use inequality as in your textbook. The reason is because when you deal with inequality, it's very difficult to just adjust the sign. Okay, so I have mu L, take away the mean over standard deviation. So this is a formula, correct? Equal to my lower possible Z alpha over 2. My lowest possible Z alpha over 2 is this one. negative 1.96. So I put down negative 1.96, right? So I rearrange this, I will have this. Here you bring over, you got minus. Okay, so this is lowest possible, highest possible. So that's why we come up to the formula. The predicted population mean will lie between the lowest and the highest. So this part, we call it margin of error. I mean, the error that we may make in the predictions of the true population mean. Clear? So now, from here, okay, everyone, are you okay so far? So in your report, when you write, right, you can explain it in this way. So now, student, are you okay? Okay, I start from the very beginning to give you the, okay, can you please take out your GC? Okay, which part must you go to? You go to stack, select test, go to Z interval. Do you have that? Okay, so there are a few things that you have to key in, correct? Yeah. You have input, as stated in your textbook. You select stack. Select this one. Then standard deviation. Please bear in mind. Standard deviation must key in 1.36. Are you clear? Okay. Then after that, the sample mean, key in 15.9. Yeah. Then the N, they have the N, correct? Am I right? Are y'all following me? N is equal to 30. Okay. Confidence level, key in 0.95. I can change the confidence level. So you have to read the question carefully. Okay, so then you put enter. So you got this value. So this is, okay, so everyone bear in mind. Okay, for me, when I interpret, so you see the last part of question 7. So this is a must to write. Other than writing this, you must write this. So we are 95% confident that the mean fat content of K-type, up to me lah. This is my own problem of pastry produced by Mr. X. Okay, for me, I prefer not to say lie between. I prefer to say it like that. Produced by Mr. X can be as low as 15.4 gram and go as high as 16.4 grams. So any value in between here. So now why we want to find this confidence interval for? Okay, so now in science it's like that. After you have this, correct? You got your result already. So you have to see whether this one support the hypothesis or not. Am I right? In science. You all do a lot of chi tasks, right? So now I want to ask you, does this support our original something said by Mr. X here? Mr. X say what? No more than 16 grams. So what can you say? Now go back to here, make your conclusion. So how to make this conclusion? Okay, hypothesis not accept. So now what we want to do is, in this case, we always say evidence-based. Evidence-based means this sample. So we say that this evidence. This evidence what? Does not support Mr. X claim because the predicted mean fat can be 16.4 grams, which is more than 16 grams. You see? Or you can state it in such a way that we have sufficient evidence to reject. That one, everyone find it a bit difficult. You use the word doesn't support. It's easier for you. Okay, we also can state that we have sufficient evidence to reject Mr. X claim because the highest predicted is 16.4 grams, which is more than 16 grams. So depend on the claim. Are you clear? So the purpose of us finding confidence interval is to what you so-called justify a claim. Are you clear? You don't find it for fun. Do you get me? And how to find the confidence interval? We do it by using a point estimator, and based on the central limit theorem, you predict in a range form. Okay, you need time to go and digest. You may want to read through the whole textbook again, then go through your notes again, then you should be able to understand the whole thing.